I really appreciate it. Uh, my name is Arun, as Mahmoud introduced. I work as a SRE engineer in Prism Analytics. In Prism Analytics, we do use a lot of Python. We do use it for automation framework. We use it for our build system. And I'm going to talk about some of the things which we do using automation framework here. And this is a safe harbor statement. Whatever I talk or whatever I posted here, I'm not responsible, or Workday is not responsible. So yeah, I'm going to skip that. And then this is the agenda I'm going to talk about. I'm going to give you a high level overview about what is Prism Analytics, what we do here, and what makes a good automation framework, and why do we use robot framework and its different use cases, and how we extended robot framework to different frameworks used to use the power of Python, and what are the issues we faced in robot framework and how did we overcome. So I'm going to talk about those things today. And a brief overview about Prism Analytics. How many of you here are Workday customers? How many of you, I will reiterate, how many of you know about Workday here? Actually, it's not many actually. Workday is a SaaS-based, on-demand HCM, human capital management and finance management tool. We are a cloud platform for ERP financial management. In Prism Analytics, what we do is we have Workday data, which is basically employee data or payroll data or finance data. And then we have non-Workday data like stock data, like JB Morgan or Fidelity. So those data are in two disparate systems. So what we do here is we combine them, we transform the data, and you get insights from the data. That's what we do. So I'm going to give you a very high-level picture about what it does. This is a data preparation tool where you can see we are passing a comma-separated file here, and then you can actually see a glimpse of distribution about that particular field. You can see the top field is highly distributed than the lower field. So you can get a glimpse of using the sample data. And then we also, once your data set is created, you can also see your data set, how it's created. And then you can also use the inbuilt Workday security model to assign permissions to who not to see the data set, who can see the data set. So the security is built into it. And also we also have a row level security where I cannot see my manager's data, but my manager can see my data. So we have row level security also. And we use this beautiful data discovery tool where you can visualize things. It's interactive, so you can drag and drop and get insights from it. So we rolled this out this year, so it's a pretty cool tool. Check this out. Now I'm going to talk about different kinds of automation framework which we use in Prism. So this is a boring test pyramid. Everybody's seen it. So you can see our stack is basically Java. So you can see we're using unit test, JUnit, and Scala test. Mostly our backend is Java and Scala. So we interact with Hadoop and Spark. Basically, they're written in either Java or Scala. And so what I'm going to talk about is all the four stuff which is highlighted there. End-to-end, E2E is end-to-end testing, and UI testing, and performance, and scalability. For those, we use Robot Framework. Robot Framework is it's Python-based, but it can actually capability to talk with Java, also using Jython. And I'm going to talk about Locust. That's where we extended Robot to Locust. So how we use the same Python library which we use for Robot, extended to Locust. Okay, what makes a good automation framework? These are the few things you can have a lot of labels here, but some of the things it caught my mind is configurability. What I mean by configurability? So which means when I run automation framework, when I create automation framework, I want to make sure that my automation runs in all the environment, irrespective of the it could be running in Windows, Linux, Docker, VM, bare metal, wherever, and I could be running in Firefox. I could be running in Chrome. My framework shouldn't run only on IE. So it should run on all the Chrome browsers. It has to be reusable. So whatever library I write, it has to be used by other developers, and it has to be collaborative. And it has to be reportable. What I mean by reportable is after running the automation, I want to make sure I get insights from the test automation results. Are my tests are running properly? What are the tests actually failing consistently? What are the tests are flaky? So I need to get a view on that. And then it has to be scalable. So my framework shouldn't only run 100 or 200 test cases. It should support 100,000, 200,000. It should scale. And that obviously, if it meets everything, it has to be maintainable. So I don't have to keep on the new developer who just joins the company. It's not easy to understand the code. So those are mistakes a lot of people do it with automation framework. So one of the reasons we picked Robot is it's purely Python based. Anybody can learn in a faster time. It's functional testing based. It's keyword driven test framework, and also it's the test case which you write in a clear text format. Anybody can read it, and it's customizable through Python or Java. So Java through Jython, and it's really reusable. And also it's reportable, where you can get the results in HTML and XML format, and it's very powerful. It's very customizable. I could use their public API. I can do whatever I wanted through the Robot framework. I'm going to give a little bit of example about it. So this is a simple example. I copied it from the website. So you can see, you can read the test case, what it does actually. I'm trying to log into a web page. That's all it does. So you don't know anything about what the library does behind it, but I can read it. So this is one of the biggest powerful feature of Robot. And also it supports behavior driven, like Cucumber Behave. So they also support Gherkin style format. This is a simple example of a Robot library, how it works. You can see this is a simple calculator app, I would say a test library, where you can see you can push a button, you can push multiple buttons, and then is my data is right. I expect some failures. Is my data is giving division by 0 error. So you can write this library. I can write a text file like this, and then I can run my test. After you run the test, you get beautiful report like this. I wish our automation is green like that. So typical Robot layout. This is our Robot layout. Different people use differently, but the bottom layer is the application which is under test, and then you write test libraries, which is basically Python, and then you write Robot libraries, which is again Python. And the main difference between these two test libraries and Robot library is you write logic in the test libraries, but you won't write logic in the Robot libraries. You only write the logic to pass the test case or not, because the main reason is in future you could change your product feature. The functionality doesn't change, but the logic changes. So you change the logic in test library, but you don't change the Robot library. So which makes your code very maintainable and reusable. That's a big powerful feature here. And then we use test suites, which is nothing but robot files, bunch of robot files. And then we use Robot framework as execution engine. And then this is a typical backend layout, where mostly we use request library. Anybody heard about request, Paramico? Yeah. So we mostly use it for backend. And then for UI, we use request module and Selenium mostly. There are a lot of other libraries, but I don't have time to talk here, but probably another meetup. Also, we use it for performance testing. Also, we use a hybrid of backend and frontend. You can see some of the library which you used in backend and frontend, we are using as a hybrid approach here. So we run it as a performance regression testing here in this case, as a Robot. It's not meant to be, but we are using it as a performance regression, because basically what the library is Python here. I can use it whatever way I wanted. And then we also use it for scalability and reliability testing. So you can see we also use Robot, and there's another framework called Locust. Anybody heard about Locust? No? Yeah. I'll be talking about that later. It's a load testing tool. So the main advantage is the Robot framework is extendable. So I can use the same library which I get in Robot, reuse it in Locust. So that's what I'm going to talk about. Yeah, that's the next slide. So what is Locust? Locust is a load testing tool basically, but I can use it for any purposes because it's written in Python. It's highly hackable. That's what they say in the website. So you can write custom clients to anything. So I can write it to a REST API. I can write it to a UI Selenium. I can write it to a Robot app actually. So whatever you see in the Robot library, actually I create a client to that and then run Locust against it. And then it also has beautiful results. It gives me results in a HTML format. I can also download as a CSV, so that I can push it to S3 and then do some further processing. And then it scales multi-node. So I can have a master worker architecture where I can scale from 100 million requests to 1 billion requests. I can actually do that. So this is a simple example of a Locust. You can see I'm trying to run 2 queries here, query 1 and query 2 concurrently. And then I give a task, and then each task has a weight of 10, and query 1 has a task of a weight of 10, and query 2 has a weight of 1. So which means query 1 is 10 times executed more frequent than query 2. And one of the things, Locust actually is based on G events. Anybody heard about G events? So it's a coroutine based concurrent programming. It's like Golang. So they support both 2.7 and 3. So yeah, so the result looks like this. You can see test case name, and then what is the number of requests and number of failures here. So, and also I can see the failures and exceptions also when it happens. And then what is scalability and reliability testing? What we do here. So we use longevity testing. So longevity testing is nothing but running your tests for a long period of time on a machine. So why we want to run longer? So since our application is Java, it tends to have garbage collection. It could get into deadlocks. It could get into a lot of other concurrency issues. So we want to identify those before customer hits. So that's why we run longevity testing, which is using Locust. And we do load testing. So we want to simulate hundreds of users, thousands of users hitting our web framework. So we want to make sure our web framework is much stable. And we also use it for stress testing so that we want to make sure we identify all the concurrency issues before customer hits. And we also use it for fault injection testing. What actually means is we inject failures, and then we expect system to be resilient. So if something happens, when you inject a failure, if application fails, then it's a failed test case. So the main purpose of fault injection testing is we want to make sure our application is resilient. And then, okay, I talked about robot and Locust. What's the main issue with robot framework? One of the main issue which we had several years before, it's sequential execution. More the tests we add, more the time it takes. So our test took from 3 hours, 4 hours to 24 hours one day. So we decided it's not going to scale. So what do we do about that? So what do? Obvious solution is run things in parallel. So you're going to run multiple robots in parallel. So we built our own parallel robot framework, which we call it parallel robot framework. Probably we should name it better. It's an internal tool used for running our test suites in parallel. So one of the main objective of that tool is to reduce the runtime and then increase the resource utilization. Some of the features which we included in the robot framework is basically based on multiprocessing rather than threads to avoid GIL, but at cost. So processes are heavyweight. And we have a heuristic-based priority queue where you can prioritize a task so that it can run first. So, and we also build a dependency graph. So when you write a test, you have a lot of dependencies. So you don't, so you cannot do it manually. So you have to write a dependency graph and then send it to a system, and system will execute it much better. And then we wrote a DSL on top of the parallel robot framework using JSONnet. It's open source by Google. It's a templating engine. It's similar to JSON, but it does a lot more programming capability. I'll show an example how the DSL looks like. So in this case, you can see it's a JSONnet file where I have a variable. Typically, JSON file doesn't have a variable. This is JSONnet, so it's a templating engine. You can see I'm running a setup. I'm running another dataset setup, and then I'm running things in parallel. So I cannot run the sequential setup along with the parallel, so I can orchestrate things which way I want, but it's easy to write. Rather than writing shell script or Python, I write it in a DSL language, which is very powerful because a lot of people can easily write a test suites and they can exclude it. I can say how many number of processes I want to run, 15. I want to say I want to exclude test these particular tests, and then I want to say I want to run this particular test in sequential. So I can do that. And then how it works internally, I said we use a dependency graph. So we have test suites, which is a robot file. It's a clear text file, so we pass it. And there is a metadata about all the dependent test suites. So we create a dependency graph out of it. So once they have a dependency graph, we send that to a priority queue. and then priority queue send it to another queue called job queue. So there will be a pool of workers which will be running all the time. So so when there is an item in the job, it will pick it up and run it, and then it will take another item from the queue. So when there is no item, all the workers will stop, and then automation will stop. So and then once you run all the tests in parallel, so we consolidate all the results, and then we will get one single result. What are the future work we're going to do? Probably we're going to open source this tool sooner, hopefully. And we want to scale horizontally. Right now, it can only handle single nodes. And we need to have like log support, shared resource. Or sometimes when you run things in parallel, you want to share variables, something like that. We talked about, so okay, I'm end of the presentation. So how we use Prism, Robot Framework in Prism Analytics, what are the different use cases, how did we use Robot Framework to extend it to multiple other third-party libraries like Locust, and then how did we use parallel Robot Framework to expedite the robot execution. Yeah, wrap. So we are doing a lot more interesting work. We not only use a Python shop, we use the Java Scala also. If you're interested, we are also hiring for different positions. We are hiring for DevOps, estates, software developer engineers for both backend and UI. And so you can take a screenshot and go home and scan this QR. Yeah. Thank you so much.
Thank you, Arun. Questions about automation? What I'm kind of curious about with Robot Framework is like, you know, you say it's very extensible, and usually that sort of extensibility like kind of lends itself to like sharing extensions, you know. And so what does a plugin for Robot Framework end up looking like when you use a third-party one? Like, how do you find it? There's like for Django, there's Django packages, you know, a website.
Yeah. So usually all the libraries which we wrote internally, so we're not looking for plugins outside. So we as I said, we use request Paramico. So most of the tools are internal. So some of the plugins which we use is Selenium library. So the Robot Framework supports it inbuilt. So we can go to we can download it from the pip also, like for the Selenium library. So there's another one for I forgot for running the UI tests. We have the XVFP plugin. So but there are a lot of other open source options which you can search online. But mostly our tools are built inside. So yeah, so yeah.
Open source that sooner rather than later. Question over here.
So when you were showing the Locust UI, I noticed that it had sort of a min, an average, and a max. Is there a way to get like a graph or P90 or P99 information out of that?
Yeah, actually they have, I didn't show all the UI here. They do support graph, but the only problem which we had is they only support aggregation, right? So sometimes we want individual request distribution also, how my query all my individual queries perform, right? So, but for that we wrote a hook to get individual request and then report it using outside Locust. But Locust doesn't support individual requests, but they do support aggregation. They also support graph. You can, yeah, they do that. I didn't show that here. You can take a look at the website, yeah.
I was just curious. I saw on that slide where you were. It was, I think, the config file for the robot tests. It was saying like open the login page.
Yep.
Username is and password that.
Okay.
And I was just wondering, like how it does that. Like how does it know?
Yeah. Actually, it does text. It does text passing. Robot does a text passing. So it passes the text file. It's a tab delimited. So you can pass it with the tab delimiter. And then once it reaches the valid login, so open browser to login page. It could be a Python library like open_browser to login page. Like here, in this case, push button is a method. Yeah, it's a method. But if you look at, I can say push space button, and then I can give arguments to that. So they also But I would ask you to look at the robo documentation for more information about that. There is more to it actually, but this is simple as I can give. So yeah.
Alrighty.
Yes. Thank you.
Very much, Arun.